technical track. Our focus today on this one will be AI opens more doors to personal finance management. I'm pleased to introduce and help me welcome SK Reddy, who is the Chief Product Officer, AI and M for Hexagon.
Thank you. Thank you. For the next 35 minutes and odd, I'm going to talk about what's happening in AI in personal finance. And before I get into the AI technicality, I want to ask you a question. How many of you believe you are a rational person? You're a logical and rational person. I understand logical sometimes I think may be confusing, but how many of you believe you're a rational person? Okay, fantastic. If you have not read the book by Dan Ariely, Predictably Irrational, every human being is an irrational person. We normally don't do things rationally all the time. Just to prove that one more time, which of these bet you would take? Heads, you get 100, and tails, you lose 105. Don't need to answer the question, but just answer to yourself. Or let's do the reverse. Heads, you win $105, and then tails, you lose $100. This was an experiment done with large number of individuals, and it was found that for people to take a loss, the profit has to be more than $200. But in the process, scientists found human beings are loss averse. We just don't want to take a loss. But the bigger problem is we actually seek loss or seek risk. There's a professor in Harvard, Max Bazerman. Every time the first class starts, he does something called the auction of $20. Anyone in the class can participate in the auction to win $20. The two rules. One is, of course, everyone has to bet an increment of $1. But the second rule is tricky. The winner gets it, but the second in the race has to still pay for a $20 auction. And kids, the students start bidding. Do you know what normally happens? Many times, students are bidding more than $20 for the $20 note because you just don't want to be that second person. And the record was $204. There was one in 1 year, students were bidding $204 to win that $20 note. I'll talk about what's happening in personal finance management. You may already have apps from your bank, which is telling you, when to apply for a credit card, when to apply for a loan, when it's time to pay off your credit card, when not to buy some item on lease. Many times when you get these recommendations or suggestions from the bank, there's a lot of AI going on in the background. In a 30-minute session, 35-minute session, obviously I'll not talk about all the potential use cases, but I'm actually going to touch upon a few use cases in personal finance management. The point I'm trying to communicate in this session is it's extremely easy to build an AI-based PFM models, especially if you guys are looking to start a company in the personal finance. There's lots and lots of investments going around, VC world, and it's extremely easy to develop an AI-based model. These are a quick view of some of the classifiers, machine learning classifiers. By the way, I'll be making an assumption about you guys that you have heard of these terms, and if not, maybe we can talk offline. These are some of the very fundamental classifiers available, machine learning, which have been there for the last 40, 50 years. Some of the framework which are being used nowadays to develop models based on these algorithms and based on these techniques are available off late, but they've been there for the last 20, 30 years. You would be surprised to hear how powerful these models are to build some of these personal finance AI-based models that will help you predict who's going to be getting the next credit card, who's credit worthy, which customer is going to be a repeat customer, all of that stuff. I will not explain each of how these classifiers work, from the simplest linear regression to logistic regression to support vector machines, naive Bayes, random forest. Many of these techniques can be used. I have a YouTube channel, just in case if you guys are curious, you can go to that YouTube channel and check. I have a lot of videos where I talk about classical machine learning based techniques and deep learning based techniques and how you can solve problems, including image processing, text processing, Wi-Fi signal processing too. In the context of the deep learning world, I think these look less sexy because classical machine learning techniques are not as exciting, but these are really powerful to develop a solution for you. So I don't have a slide for clustering algorithms, but these are typically the classifiers. But using a combination of classifiers and clustering methods, you can actually identify and develop a lot of solutions in AI. The first thing you could imagine in a personal financial management is credit scores. Historically, I think you would have heard Experian and some of these credit tracking agencies. They've been creating a credit score based on certain very few data points, including your spend and stuff. But of late, many companies are using additional data, including FICO themselves. They use additional data. If you look into the traditional data, you have some basic information about what they've been collecting, but then you also have a lot of alternate data, including your social footprint. What is it you're doing online? What purchases you have made in the recent past? Your the apartments you live in, or the cars you own, and other stuff. And the algorithms they have been using is also very classical machine learning. But let me come to more exciting use cases in a minute. But again, Zest Finance, another startup company that has been popular, which also has been using some additional data to identify to predict who's going to be more creditworthy. Now, I'll spend a couple of extra minutes on this slide. And by the way, at the bottom of every slide, I have the link which leads you to more information about that information, what I have. All the presentation today, I will not be talking about what I've been doing in my company because it's an IPNL stuff, but some of these papers and published information are motivation to many companies, including some of the companies I've been advising in the Bay Area on developing PFM models. For example, predicting creditworthiness, especially in the context of when you don't have enough information about the user. In other words, it's called limited scoring data. It's called thin file customers. If you don't have, let's say you're a student and you're applying for credit card for the first time, or you just came into this country, or you happen to be in that area for the first time, and then you did not do much of purchasing and selling in the previous years, and hence the companies don't have enough information about you. How would you define? Now, using support vector machines, or logistic regression, or random forest even, if you look into the number of features available, these are the list of features. The font is too small. This is basically information asking for what amount of loans you have taken, the number of loans, how much you have paid, the stability of your job, the locations you lived in, and a couple of other features. Now, not every company uses the same set of features. For example, I've heard one of the companies which I think from this list, they also use what type of mobile device you use. Here is a thumb rule. If you happen to be using an iPhone, the probability of you getting a loan is higher. And I'll talk about some other predictive analytics summation rules. But in this case, if you look into the paper, there were 3 fundamental machine learning techniques used. One is support vector machines, card, classification and regression technique. This is logistic regression, and then cascade correlation neural network. Cascade correlation neural network is nothing else but a simple multi-layer perceptron of 3 layers: input, output, and hidden layer. and with some minor modifications in terms of the architecture. The creditworthiness, if you look into just these three basic models, the most simple models, the accuracy rates are above 95% or close to 95%. Creditworthiness. And that too, using around 15 or 20 features in developing a model. Let's get into fraud detection. There are very traditional historical fraud detection is you have those at the real time at the terminal. You actually have to have the right pin you're punching in or Face ID, and if you still get the right pin ID, there are some heuristics. For example, if you have just purchased an item using your credit card and your geography happens to be in Paris, and an hour later you're purchasing something in United States, the probability of you reaching Paris from Paris to United States is more than an hour, then that's a basic heuristic suggestion that, okay, this could be a fraud. And even if that system fails, there are certain rule-based and machine learning-based methods that will detect fraud. Fraud is an interesting situation. If you look into specific data science methodology, you need to have a balanced data set for any interesting, any intelligent model. You would not find a balanced data set of a fraud transactions. The percentage fraud could be 0.01 or 0.1% of the whole transactions. Now, there are a few data augmentation techniques. You can do oversampling or undersampling and SMOT and other methods, and you can also do synthetic data, but sometimes the model is not very intelligent. There are techniques for that too. Single class SVM is one of the most commonly used technique for fraud detection. So in this paper, again, the reason I bring this paper to you guys, and as I mentioned to you, the objective of this session is to show you how easy to build some of these personal finance models using the data sets available online already. In this case, authors actually used 8 to 10 different methods, and the interesting part is there are certain classification methods and some clustering methods to identify. And the experiment, what they did also was, if you look into the allocation of the data for testing and training, you have as one extreme of 50-50 to 99-to-1%, which is not normally done. 95-to-5 or 90-to-10 is what I would recommend for a fraud detection. But if you look at the machine learning methodology, expectations maximization, k-means, farthest first and x-means. Farthest first and x-means are variations of k-means of clustering methods, and density-based is another variation of k-means, but identifying clusters of data and identifying the density of assigned to each of the point that's coming in. And classification is you have naive-based, support vector machines, logistic regression, and decision trees. And the decision trees can be a variety. You can also have random trees and multiple decision trees. Again, if you look into the model accuracies based on these 4 or 5 algorithms, I think accuracies are really high, above 95%. In the context of fraud detection, I would recommend, if you're using classical machine learning, of course there are a lot of people using deep learning methodology, but if you're using classical machine learning techniques, I think SVM would be a fantastic model, because SVM has this inherent talent of not getting overfitted, and also sometimes it manages when data is missing, some data is missing. So that's the benefit of it, whereas that's not the case with logistic regression and other methods or clustering methods too. And if you look at the F1 scores, do you guys know what an F1 score is? For any classification models, you use the performance of the model is measured in terms of precision and accuracy. But many people feel that precision and accuracy are still not really reflecting the capability of the model. So there was a new metric that came out where it's called F1 score. F1 is equal to twice of precision times accuracy divided by precision plus accuracy. It's another metric that directly works on both precision and accuracy, and that's supposed to be more reliable than just pure precision or accuracy too. So if you have a controlled normal to fraudulent transaction ratio, and this is the performance of various models here, you see the best one is SVM here, and in the uncontrolled normal to fraudulent transactions here, where the data is coming in a stream and you're not really controlling the data that's coming in, you find again SVM doing a fantastic job. So if you're working on a fraud detection model, it could be warranty fraud, credit card fraud, any type of fraud. And when I say fraud, I want you to even think in terms of more of anomaly detection or even novelty detection. The term novelty, anomaly, fraud is all interchangeably used in some situations, but the domain context will impose the restrictions in terms of what the model should be, the parameters for the model is, and the features is. Now, in data science, in machine learning, we all have been hearing this, that we need to have huge number of data points to develop a model, right? If I ask you, can you build a model on just 4 data points? Actually, no, 2 data points for training and 4 data points for testing. It doesn't sound right at all, okay? Let's keep that point on one side and let's come to a different point. I don't know, you guys track what's happening in the market today, of late. There is a huge amount of chatter going on that we are going to be seeing recession very soon, right? Now, the way a recession works is you would not know that you're in recession when it starts. Only when you are deep into recession is when you know. Because the classical definition of recession is 2 consecutive diminishing quarters in GDPs. That means you have to wait at least for 6 months to know that you're in recession, but actually recession has already started. So instead of forecasting recession, which also you can develop models, but can you also do nowcasting? I never heard of the term earlier till I read the paper, but nowcasting recessions to identify, are we in recession? And in this case, the model actually has a granularity of a month. Every month, the model can predict whether you're in recession or not. So they took the data from 1973, I think, to 2010, out of which I think 1973 to 1986, something, they took for training purposes, and the rest of the data period as testing purposes. And in the training purposes, there were only 2 recessions as announced by National Bureau of Economic Research, I think NBER, and the 4 other data points was used to test the model. And this model also actually came out really well. And they used SVM to compute. As I mentioned earlier, SVM can manage data when you don't have enough data or sometimes the data is missing. Now, if you look at the graph here, the NBR recessions are those gray color recessions as announced post facto 6 months later, but the models were actually predicting very accurately even on a month-to-month basis. Here is a question for you guys. When you're training any machine learning model, you normally take the latest data, especially more precise data. Initially, you took certain data and you realized, oh, the data was wrong. You normally go back and modify it, right? That's what you do for machine learning models? Yes is this, no is this.
Yes.
Okay. I think it may be coming a little close to lunchtime. Maybe that's why you guys are distracted. In this use case, predicting or rather nowcasting recessions or even forecasting recessions, you might have heard every time, or typically for 1 or 2 quarters, government goes back or NBER goes back and modifies the GDP numbers of the previous 2 quarters because it's inherently not possible to compute most accurate GDP growth at the end of that particular quarter. You got to wait for some more information. But they normally, at the end of the quarter, you make a prediction and then go back and modify it. The question for you, I won't tell you the answer, but think about this. If you're training a model for nowcasting recession, and if the government announces the modified numbers for GDP after 2 quarters, would you go back and use that data to train the model to improve your accuracy, or you won't? That's my question. If you want to know the answer, talk to me after the break. That's, someone told me a long time ago, if your presentation is just before lunch or just after lunch, people I think may not be that paying attention. So the best way of making sure that they pay attention is ask a question and then ask them to talk to you after the session is over, so that I think they'll come back to me. Predicting stock trend, not actually the stock price. I work for this, I've been actually helping this Bay Area-based company which actually works with hedge funds, where they make predictions on what the stock price is going to be. Normally, I would imagine you would want to predict the stock price maybe in the next 1 hour or 1 day. But some of the models these companies are working on is to predict even 1 day, 1 week later what the stock price is going to be. And they actually have really interesting models available. But in this case, extremely a simple model. How do we predict the trend of the stock price? Whether it's going to go up, go down, or stay same. It's not the perfect stock prediction model, but if you want to dabble yourself and find out, develop a model, it's a very simple model available here. It's actually published in December of 2018, just a couple of 4 or 5 months ago, on how to predict. Now, predicting based on news, in other words, using sentiment analysis, 2018, year of 2018 has been a fantastic seminal year for all NLP enthusiasts. I don't know how many of you are NLU and NLP enthusiasts. 2018 has been a fantastic year. I remember developing a couple of sentiment analysis models in 2016. We were really struggling with starting with one-hot vectors to GLOV vectors and word-to-vec vectors. But in 2018, 3 or 4 models were released. One is called BERT, B-E-R-T. Another one is ULM Fit. And another one called actually Transformer from both Google and also Fast AI. Using any of those models, just input series of sentences into the model, and the model will tell you what you're asking for. You're looking for the sentiment, it will tell you the sentiment. There's a positive sentiment, negative sentiment. If you have missing words, it'll tell you the missing words too. But anyway, coming back to this use case, if you're looking for developing a stock trend prediction model using very simple NLP methods, you can actually pick this. Credit risk. Okay, I've given you the loan. I'm a credit union. I want to find out how much risk I'm getting into. Are you going to pay back? 3 very simple techniques were used. AdaBoost, it's called adaptive boosting. Have you heard of XGBoost? Extreme gradient boosting. AdaBoost is one of the precursor to XGBoost. If you don't know any technique, by the way, this is my suggestion. If you don't know any classical machine learning technique and you're trying to do some classification, if you want to pick one, use XGBoost all the time. Having said that, in this paper, the authors used AdaBoost, it's called adaptive boosting, which is more of just boosting the learning process. And then you have the gradient boosting and then logistic regression. Predicting the risk, again, is so extremely simple and easy if you have just a little bit of data points about the customer. And the area under curve is more than 70%. So the models actually was at least 70% of accuracy predicting the false positives, false negatives, and true positives and true negatives. I'm actually going to skip this. In digital marketing, if you are a startup company or a big company, you want to motivate customers to come and purchase your product and services, and you have many techniques of doing it. You actually have coupons and discounts and stuff. But the problem is, you have a limited budget, and you don't want to spend that money on those customers who would have otherwise bought the product. So there is the concept in digital marketing called uplift modeling, where you want to find out the so-called the persuadables who can be persuaded by discounts or reaching out or connecting or customer service, who would purchase because of these treatments, and who would not purchase if you don't do those treatments. Classical classification models in digital marketing has been identifying which customer is going to buy or which customer is not going to buy. But those models were failing in the sense, if you predict someone is going to buy, maybe the person was already interested in buying without any encouragement, but if you want to do that. Uplift modeling is one of the, in using AI, artificial intelligence has been one of the techniques which have been used by many companies. These are some of the areas uplift modeling has been done. If you're selling apparels and toys and books and alcoholic beverages and pharmaceuticals and sports and stuff. And around 45 to 50 features you normally use. I'm going back. And you use uplifting techniques on top of your basic classifiers. How would you do it? You have your A/B testing and some other method of identifying the potential customers who would purchase, but what you do as a next step is not only you identify who would purchase with and without treatment, so you need to have a control group and a treatment group. And that information, once you have this supervised information, you can run some of the basic classifier models to identify who would purchase based on treatment. These are some of the graphs you normally see when you have uplift models, where you find customers who would purchase with basic information and who could be convinced to purchase based on additional treatment. No machine learning presentation or artificial intelligence presentation is complete without talking about deep learning. Autoencoders have been used for the last 4 or 5 years trying to cleanse the data. If you have incomplete, erroneous, noisy data, how would you clean up? You can use neural networks, which actually you can input the so-called noisy data, and then at the end of it, you actually get cleaner version of the same data. Now, how does it work? You can go back and read about how autoencoders work. There are different types of autoencoders. You have variational autoencoders, you have denoising autoencoders, and stacked autoencoders, bidirectional autoencoders. There's so many stuff going on. Using autoencoders, you can find the latent representation of a customer. I don't know if that phrase is familiar to you guys. You can run classical machine learning models using a bunch of features for a customer, let's say gender, age, and earning capacity, and an apartment, or yes or no, or car, yes or no, and stuff. But if you have more number of features, you have this curse of dimensionality, and you can reduce the dimensionality, curse of dimensionality, or manage the curse of dimensionality by running the data to multi-layer perceptrons and create a latent representation. In other words, you can convert a customer into an n-dimension vector, which could be used to plot in an n-dimensional space. And from the n-dimensional space, you can bring it down to a two-dimensional space called t-SNE. There's a technique called t-SNE, T_SNE. And once you start plotting various customers, you see customers fall automatically into certain clusters who all come together, and each of these customers have certain unique and similar feature which makes them fall into one cluster. This is a fantastic unsupervised data. Till now, I was talking about in classifiers models, you need to have a supervised data. You need to have data where you collect who's going to purchase and who's not going to purchase, and then using the supervised data, or label data, you can run a model. But if you don't have supervised data, how would you do it? Then you actually do clustering, and latent representations is one of the fantastic ways, and deep learning actually helps. So by learning the latent representations of a customer, you actually can plot the customers into various clusters, and then you can identify what seems to be unique about them. Quick information about how to predict bankruptcy, and after this I'm going to open for questions. if you are a mid-sized company or a big company and trying to give loans to a small company, which is a one-person company or a small company, you want to also find out what's the possibility of the companies going bankrupt. And then this is a paper published, I think, in 2000, I think recently, I forgot the time. Around 10 to 11 techniques were used to identify, and this is supervised learning again. So you have the logistic regression, you have the perceptron, and then you have the deep learning networks. They have multiple classifiers. Then you have the LDAs, KNNs also being used on naive-based classifiers. Using a very few features, you can run these models to identify, and there's a lot of comparative analysis. Of all these models, the paper summarizes, and I also believe personally, the model that would work the best would be a deep learning based model, some sort of a neural network based model that would work. I've been asked to tell about this company which actually has a deep learning management platform. You can go check out them, and also there's another company which helps if you have any AI based needs. Bye. Thanks. I'll be happy if you have any questions.
So you said 2018, three deep learning releases, Google, BERT. What were the other two?
Google's model was called Transformer, and BERT, B-E-R-T, is one model. Another one is called ULM Fit, ULM Fit, F-I-T, that's single word. And another company called Fast AI, which is also, you should check out if you don't know what it is. Fast AI also have their own version of Transformer. These four models has made a dramatic impact on NLP and NLU.
The question is this, like, a lot of these models, great prediction, can really help the financial space. But how do you convince a company, like a bank, that use my model and make a loan based on it, right? I mean, they'll say, like, put your own money if you feel the accuracy is all that good.
Yeah.
Because they've been using anti-variant models, but it kind of works for them. So I don't know if you've encountered that.
Today's session, I think, is not in that area of study, so I'll not be able to answer the question. I do have an opinion for that question, and we can talk offline too. To convince a company to adopt an AI model, it's not the topic today, but it's a very common thing. Yes, common thing. But Accenture and PwC has published two different reports in 2016 and 2017. Of all the industry verticals, financial services is the most advanced in terms of adopting AI. So I'll be surprised if an AI financial service company even questioning the veracity. They may say, okay, let's do a limited amount of testing where we can do maybe pick a geography, pick a customer base, a small customer base, and test it out how it works, or we can analyze your model, see if that works or not. There are AI methods available. You can bring in AI experts to analyze as a third-party company to analyze the model to see if it's really a good model. Because there is good amount of supervised data available for all types of financial transactions, as wide-ranging as African banks to German banks to European banks to even some of the Asian, Korean banks. I've seen published data available as low as 10,000 data points to a couple of million data points available too. So you can cross-verify these models with some of the data available. So there are a lot of ways of doing it. So I'll be surprised why they're not using it. Yes, go ahead. Yeah, go ahead.
Do you have a link to the slides? We can check out the links that were in the file.
I have not shared the presentation with the organizers. I don't know what the method is. I'm going to send it to the organizers, and maybe they'll send it to you. But then it will not be a clickable link. You just have to type the whole stuff, I think, because I'll be sending a PDF document.
Okay.
You had a question too? Yeah, go ahead.
A lot of the techniques that you show are sort of classical machine learning. And so is there something about finance that lends itself better to those classic techniques as opposed to deep learning?
No, there are lots of industry verticals like healthcare, which also works with classical machine learning techniques. See, I personally prefer deep learning techniques because I think it's the need to do feature engineering is not there as much in a deep learning approaches compared to classical machine learning techniques. But for a deep learning, you also have the computing costs going up, and sometimes even the resources, the engineers who actually can do a nice architected model, I think it's more difficult compared to a classical machine learning. For example, XGBoost, I think there's a guy by name Chen wrote a library file around, which can be easily downloadable on GitHub for XGBoost, and you just have to a single sentence code you write to run the XGBoost model, it runs in milliseconds. Even for 10,000, 20,000 data points, it runs in milliseconds. So the cost of developing models, I think, is extremely cheaper in a classical machine learning techniques. But there is a debate going on whether it's deep learning or ML or versus DL. That's a different topic. Yeah. Okay, thank you very much, guys.